So this question says an electric lift with a maximum load of 2000 kg along with the lift plus passenger, the mass is 2000 kilograms, is moving up with a constant speed of 1.5 meters per second, and a friction force is opposing the motion, and the friction force is 3000 newtons here. So this is the lift. The mass of the lift is 2000 kg in total, right? And there is a friction force of 3000 newtons opposing the movement of the lift upwards. Okay, so this is the cable wire that is pulling it up with some tension T, and the lift is overall moving upwards with a velocity 1.5 meter per second. It is moving up with a fixed speed 1.5 meters per second, right? So we have to find the power delivered by the motor, the minimum power delivered by the motor. Okay, so what is happening here? There must be, so what is the weight of this one? So the force of weight on the lift is 2000 G, that is 20,000 newtons here, right? G has to be taken 10. And then there is a frictional force as well, worth 3000 newtons. So in total, the force, downward force on the lift is 23,000 newtons, right? So the minimum to pull it up with a fixed velocity, the minimum tension that this cable, right, must be applying on the lift is equal to 23,000 newtons, right? Fine. So the power delivered is going to be, power is what? I have to find the power delivered by this tension, right? Because the motor is running, is driving the tension. Okay, the motor is running the tension, the rope is drawn by that tension. So the motor actually is responsible for the upward movement of the lift, right? So the power due to that tension is going to be T times velocity, right? Power is force into velocity. The force T is T times velocity or the speed. So this is going to be 23,000 into 1.5. Okay, if you multiply, this is going to be 34500. So this becomes the answer here, right? Power is what? I am using this formula. Power is force into velocity. Okay, force into velocity. It's not cross product actually. F dot V, power is the dot product of force and velocity. Okay, so I'm using this formula here and getting this answer straightforward, 34,500. This is the minimum power that the motor has to deliver. Okay, it can be more depending on the situation if there is some other inefficiencies involved, right? So but this has to be the minimum power that has to be delivered to the lift. Okay then, thank you, bye.